Hello friends, welcome to today's lecture, Shear Force and Bending Moment. Myself, Mr. Y.S. Patil, Department of Civil Engineering, Sharad Institute of Technology, College of Engineering, Yatgaon. So, let us one problem, that is overhanging beam. Draw a SFD and BMD for given beam. Now this is the overhanging beam that support A and B, and the BC portion is overhang. In this beam, the external applied forces is 3, that is 20 kN at point C, 40 kN at point D, and a UDL having 20 kN per meter intensity from A point to D point. So first calculate reactions. So first summation Fy is equal to 0. So total number of forces in a vertical upward direction or vertical direction is 5, that is 20 kN first RB, this 40 kN, 20 kN UDL and RA. Out of these 5 forces, RA and RB going in upward direction and remaining 3 forces going in a downward direction. So upward direction forces plot one side and downward direction forces on the another side. Then RA plus RB is equal to, first is a UDL. Intensity of UDL is 20 into length of UDL is 2. So 20 into 2 is 40. Then 40 kilonewton and 20 kilonewton. So RA plus RB is equal to 100 kilonewton. Then summation M is equal to 0. Taking moment about A. So for this 20 kilonewton UDL, directional moment is clockwise. 40 kilonewton also clockwise with respect to A. RB is anti-clockwise and 20 kilonewton clockwise. So plot clockwise moment one side, anti-clockwise moment another side. First start with UDL. So total intensity of UDL is 20, length of UDL is 2 meter, and where it is act, half of this length means this that total force of UDL is acting on this point. So distance, for this distance, half of the AD span. So 2 by 2. Then 40 into 2 meter. Then RB, direction of the moment RB is anti-clockwise. So plot another side. RB into distance is 4. That is RB into 4. Then next 20 into 2 plus 1, that is 5. By solving this equation, we got RB is equal to 55 kilonewton. Then put up this RB value in this equation. So RA becomes now 45 kilonewton. This is your first solution or first step to solve the problem. Then next, shear force calculation. So first consider sign conventions. Consider right side upward force minus downward force plus. So starting with C point, and already we discussed every point having two shear force value, that is right and left. So starting with marking a section on the just right of C and consider right side of the section. So total number of force on the right side of the section is 0. So the value of CR is 0. Then next, mark a section on just left of C and consider right side of this section. So total number of force on the right side of section is 1, that is 20 kilonewton, and the direction of the force is downward. So downward force is positive. So shear force at CL is 20 kilonewton positive. Then next, come at point B and mark a section just right side of point B and consider right side of the section. So number of forces on the right side of the section is 1, that is 20 kilonewton, and remain as it is for BR. Then next, mark a section on just left side of B. Mark a section on just left side of B and consider right side of the section. Now number of forces on the right side of the section is 2, that is first one is a 20 kilonewton, second one is a RB. So 20 kilonewton going in a downward direction, RB going in a upward direction. So 20 kilonewton consider minus and RB consider, 20 kilonewton consider plus and RB consider minus. So plus 20 minus 55 is answer for BL is minus 35. Then next, mark or consider a section just right side of the point D. Now number of forces on the right side of the section is 2, 20 kilonewton and RB. So value is minus 35. It doesn't change because there is no extra forces, only 2 forces are there. Then next, consider a section at D just left side and consider right side of this section. So total number of forces on the right side of this section is 1, 20 kilonewton, second RB and third 40 kilonewton. Downward forces consider positive, upward forces consider negative. So this is the plus 20 because there is a downward force and downward force consider positive. So plus 20 minus 55 and plus 40. So answer is plus 5. Then next, consider a section on just right side of A. Now total number of forces is 4, 20 kilonewton, RB, 40 and UDL. So plus 20 minus 55 plus 40. Now UDL. So you have to convert this UDL into force, length, intensity of UDL into length of UDL, that is 20 into 2. So answer become 45 kilonewton. And AL, consider this AL, mark a section on just left side of A, consider right side, and this is the 45 and our RA value is 45. So minus 45 plus 45 it become 0, means start with 0, end with 0. This is the checkpoint, whatever your calculation right or wrong. So by considering these points, draw SFD diagram. C 0, 20 plus 20 minus 35. Then at D R minus 35, DL plus 5, AR plus 45 and AL 0. All forces or all coordinates join horizontal and straight line between B to C, B to D. Now in between A to D there is a UDL. So SF diagram will be inclined or that inclined straight line. See here, this A to D changes inclined straight line. In between B to D there is no load, so SF diagram becomes horizontal straight line. At point D there is a point load, it changes vertically. So intensity of the point load at point D is 40. So from this is a 35, below that baseline and above that baseline is 5. So 35 plus 5, 40, means it change vertically total 40 kilonewton. Means what? Whatever this here once again, RB value is 55. So below baseline is 35, above the baseline 20. 35 plus 20, 55. This is the final SFD diagram. Then next, draw BMD. Consider or draw the first of all sign conventions. Now bending moment at A is 0. Only bending moment at A is 0 because that simply supported end, and bending moment at C is equal to 0 because free end. This is the two conditions. Be careful for that conditions. Now A and C is 0 because at A is a simple support and at C is a free end. B, now B is not a simple support, B is a continuous support because at B, right side of that B there is one overhanging portion. That's why this is not a simple support. In last lecture we consider that MB is equal to 0 because B is a simple support. But in this case, now this is a overhang beam, that's why this is a continuous part of BC. So MB value will be somewhat is there. So calculate bending moment at D first. So consider exact section on point D. Number of forces on the right side and left side. On the right side RB and 20 kilonewton, and on the left side RA and UDL. So consider left side. If you want to consider right side, you can. So I consider left side of the section. So RA value or direction of the moment for RA with respect to D is clockwise, and clockwise moment is positive, and for that UDL is anti-clockwise, and anti-clockwise moment for left side is minus. So value of RA is 45 and distance from point D is 2. So 45 into 2. Then UDL, intensity of UDL is 20, length of UDL is 2, and act half of this length, means that half of this AD span. So acting on this point. So 2 by 2. So value become bending moment at D is 50 kilonewton. Then next, sorry, this is the B point. Then next, bending moment at B. Bending moment at B, number of forces on the mark first apollic section on the exact B point. Number of forces on the right side is 1 and number of forces on the left side is 2, 3. 40 kilonewton UDL and RA. So consider right side. Direction of the moment with respect to C is clockwise and right side clockwise is minus. So force is 20, minus 20 into 1. That answer is minus 20 kilonewton meter. By using this all four coordinates, plot coordinates. Bending moment at C 0, bending moment at B is minus 20. So minus whatever the minus values, plot bottom of section or bottom of the baseline. Then bending moment at D is 50 plus 50 kilonewton meter. Plot these all coordinates. Now join. Now this is A to D is a UDL. So for A to D join by using parabolic curve. Then D to B there is a no load. So join by using inclined straight line. And B to C also there is no load. So join inclined straight line. Now this BMD diagram is cut with the baseline of this point, and this is I mark new point, that is E point, and this is a baseline. Baseline means above this baseline positive value, below this baseline negative value. So baseline value is 0. So I want to calculate this distance, horizontal distance. I know the bending moment value of this point, means bending moment at E is equal to 0 because this line is cut with the baseline. So bending moment at E is equal to 0. So I want to consider a point E and the distance x. This is the x distance from point C. EC is a x distance. So consider taking moment about E. Consider right side. Number of forces 2, 20 kilonewton and RB. So direction of the moment for this 20 kilonewton is clockwise. Clockwise right side minus, and RB is a anti-clockwise. So anti-clockwise moment will be plus. So 20, this is the force, and perpendicular distance is x. So minus 20 into x plus RB is a 55 and the distance is, this is a total x. So this distance is x minus 1. So minus 20x plus 55 in bracket x minus 1. So multiply by 55 in this bracket, 55x minus 55. So this in total equation unknown is x. By solving this equation we got x is equal to 1.57 meter from point C. This is the distance. Whenever your baseline, your BMD diagram cut with baseline, you need to calculate that distance. This is the complete solution for overhanging beam. Thank you.